Okay, and then you want to try it out, want to check it. So you now formulated your model. It's actually not that hard if you come from a one-dimensional model to make it 2 dimensions. You essentially, instead of dealing with one-dimensional arrays, now you just have 2-dimensional arrays, and it's pretty symmetrical. You just copy and paste. Instead of single do loops, you have double do loops, and so it's not that hard. And then you test it, and this is what's done here. You test the model by creating a test case, and the test case is here I consider a square lake, and initially everything is in standstill at the beginning, so no currents, no flows, everything's zero, and I just elevate the central grid cell and just elevate the sea level elevations, just increase it by 1 meter initially, and then I let go. Simulation. Here you can see different phases of this. See that this is a so-called circular wave propagating away from the center, then hitting the closed walls. So you always have to, in these numerical models have to specify boundary conditions. What's done here is that it's just all lateral boundaries are considered as coasts. Okay? So they're just prescribed as closed boundaries. And if you have a closed boundary, you get reflected. So let's have a look at the simulation. We have a look at it. Now, we go. All right. So you can see you get reflection. You get some interesting interference patterns. You learned about interference, right? And you do this type of test to check whether you made an error in the model. So how can you make errors? Well, it's pretty easy to confuse J with K. Get it the wrong way around. Okay, you can make so many little tiny mistakes, and then the model might not crash, or you get some weird results. This one you can see how nicely symmetrical the solution is, and this is a confirmation. And then you can also ask, well, is that not realistic? So in these type of models, the shallow water equation models can only prescribe long surface gravity, okay? And they have specific speed. Okay? The speed of these waves is square root g times h. H is the water depth, and you can do some comparison, check whether the it's okay. So this is your model. That's the first successful test of the 2-dimensional. Hooray!